Ladies and gentlemen, welcome to the show. Yes, Kärcher cares. And a story that goes on from this point when I published my videos is a rather amazing one. I got several mails from Kärcher, and one of them was not exactly constructive, but the other ones were. So happens that instead of sending me their lawyers and or public relation assistants with big chests, they sent me something completely different. A ball game I was not expected to handle. Really. They sent me a full-blown competent development engineer. Yes, they did. So, yep, I'll say it once again. Kärcher did send me a full-blown competent development engineer. Now, how cool is that? All of it because my unit got somehow destroyed by premature corrosion. Wow. Yeah, so with the gentleman we sat down on a coffee table and we discussed several issues. We discussed definitely engineering, and also I displayed the parts I recovered from the old units, and he took them away for further analysis. Now, that's something that they haven't seen yet to that extent, but definitely there's going to be a feedback, and production methods would probably be altered to incorporate grease, or I don't know, whatever solution they'll come by, because it's really a big piece of very nice engineering. So, injecting oil in the crankcase was an easy fix. Yes, but easy fixes apply to products that can stand them. Mostly good products, because you cannot really apply an easy fix to a lemon and expect it to become a good product. It will take much more than that. So, also in the comment section, I received a very interesting input of a viewer who claims that overloading the accumulated water tank could lead to problems. And I decided to take apart the heart of the machine, actually the blower or the sucker, well, the fan, the turbine. And this is what happens in the process. So let me explain. Water comes through this hole. Water comes from underneath. Water and air is initially aspired through this pipe. I will show it better for you. And it comes from here, where normally it would continue to go upwards, but it is covered by this part. So water will go inside, take a round trip in this baffle from the inside, come out, and be directed downwards to the tank. That's a very cool idea. It's a kind of round trip. So most of the velocity of the water will be lost at this point in time, and it will just drip into the tank. But there is more to that. So just before we assemble, I'd like to show you an important spot that you may need to clean. Now, these are the old parts. They have been used about several miles, 10 miles about. And you can see that if your device loses section power, the fix is extremely simple. Just clean this fine mesh here, right? I would use a small toothbrush or something like that, but don't force it. It's a very fine mesh, and this mesh is supposed to separate carry on the final separation between water and air, because water has to be collected in the tank roughly like that. Oops, I got it the wrong way or not? No, I got it right this time. And you can see that it's quite a way. So there is a max. Come on, camera, show it. There is a max mark here, which says that the maximum level of water you can load, it's about there. But you can see that there is a lot of reserve before it reaches the first baffle. And now this volume should be left, and it is, because when you change the clean water tank, when you refill the clean water tank, normal procedure is to empty this one, so it can never get overflown. And all this airspace here is made to kill eventually foam, forming foam, and further separate the water from the airflow. Good. Now, at top of it is the hole through which air will be sucked away. This is performed by, just lost it, a very nicely shaped, really. I mean, this is great molding, boys. Yeah, it really is. A lot of engineering went into that plastic part. It's kind of complex, very well molded. This is high precision thing. I mean, for a consumer device, come on, not everybody can afford to do that, but they did it. So it goes at top of it, roughly this way. Obviously here it will not stand because the body of the device is missing. Goes this way, and from here air is drawn away by the turbine, which is this assembly. Now, as something interesting to observe, the motor is literally corrosion free. Yes, siree. The motor is quite well isolated from the moist air. Now, whatever you do in this kind of separation between air and water, even more water with some sort of product, cleaning agent inside, you will never, really never completely separate the two fluids, water from air. It's a complex process, so some humidity will go inside, definitely. And you can see that there is some superficial corrosion on the impeller element, but this is only like a paint. It's really a very thin layer. It has nothing to do with a stable corrosion, I'll say, a corrosion that will eat things apart. No, it's only very superficial. Yeah, and furthermore, this kind of rust seems to be very stable, so actually it's an oxidizing process that seems to protect from deeper corrosion. Yeah, it happens with a lot of... Well, there's not only one type of corrosion, you know. There are several of them, and yeah, this one is very superficial, so eventually in some very long time you'll do some damage, but well, the unit will be completely outdated, and well, no, lifetime no. It wouldn't make such a big difference. Here you see it's very superficial. No. In a lifetime this wouldn't make a big problem, wouldn't make a hole. Yeah, so, and the motor goes here roughly, and air is drawn inside of the impeller and comes out. So, obviously, you can never expect a complete separation of the fluids. At this point here, there would be some moisture, definitely. And the part is coping well with it. So I put my finger inside. Surface is, no, it's good. See, I can even scratch. Not a lot's coming out. That's good. Now, here is the trick. And on this part, there is a pipe. A pipe coming from this side. So, I don't know if you can see on camera. Right. You see the hole, you see the air and light coming through it. And this is a very nice feature, meaning that if for some reason you put everything on top of the other, I'm gonna move it. If for some reason you put everything on top of the other and you let it fall, which in the normal position will fall this way, even then, if some water is to escape through the serpentine inside, well, it will not reach the fan. It will be drawn by gravity and flow through this pipe, and this pipe from here in the original equipment goes down very down to the brush assembly. So therefore, it will walk out by gravity away from the impeller and will not cause permanent damage. So even if you tilt this device too much, or even if you let it drop inadvertently, The tank of water in its natural position, the tank of dirty collected water, will be drained, if it should overflow, through this pipe before it accumulates in the fan assembly, in the air turbine assembly. Now, motor is also quite good, I may say. It's like new. No corrosion, whatever. A nice shielded, not waterproof, but shielded bearing. A lot of brush life left. Yo. I like it. Relatively fine steel. Fine laminated steel. So, you know that expensive motors have laminated steel, which is thinner lamination than crappy ones, because it reduces the electromagnetic losses by eddy currents, while cheaper motors, well, they don't really care about that. So this is a nice long running motor. Looks like some very tough plastic, which is loaded with, yeah, looks like fiberglass balls or components, glass balls. Well, it's loaded plastic. Yeah, this is really a nice piece of engineering and I like it. I conserve it because one day or another I'll make a project, a do-it-yourself project for my little girl, my little daughter. You know, maybe a hovercraft or whatever, just to illustrate the principle. So far about the impeller. The impeller sucking unit, aspiration unit, is very well made. Yeah, and apparently all the engineering toads did his job. Because humidity, which is unavoidable in the process, does not seem to cause a significant damage. That's a good point. Well, this part they know how to do pretty well. Plastic injection. Yeah, it's a precision thing. So, what I had is that it's also clicked, and there are screw assemblies, but I hate a click. Yeah, well, you cannot really have everything, so at least it's very nicely held down by fasteners with screws, and maybe somewhere in the assembly process clips make it easier. However, not exactly for disassembling, but well, this is the trend, and this is really a minor detail which will not shade out the inherent quality and engineering that went in this product. I repeat once again, you can have an easy fix on a quality product, but you'll never come with a complete solution if you apply an easy fix to a lemon. It will require too many fixes to become a quality product, and this one is. Well, the plastic is well made, quality materials, I mean, yeah. I like it. This portion of the vacuum cleaner is absolutely gorgeous. Yeah, and like the overall inside design, it's very well made, sturdy plastic. You just name it. Yeah. But what is the most important point, and this is what I want to stress out, is that Kärcher sent me a development engineer to discuss the problem with. Being an engineer myself, it was an honor, and with the gentleman we had a very constructive discussion. That's what makes a difference. I mean, face it, it's a consumer item, right? Doesn't bear the pro label on it, no way. And anyway, they care. They care that consumers would be entitled to a service which many professional unit manufacturers wouldn't do. In 20 years plus of career, I can count on the less fingers than I have on one hand the number of cases where I was sent a development engineer, and we talk about here about items and equipment with a much greater face value, actually orders of magnitude away. And here, for a wet mop vacuum cleaner, these guys sent me their development engineer. Now, congratulations. I was not expecting that, no one is expecting, but well, this is a very positive surprise. And yes, Kärcher cares. Alright. After a short break, we'll come back to one user command that says oil may damage the gearbox, and I'll try to explain why. Don't think so. Alright, at this point let's take care of the torque limiting clutch problem. A viewer suggested that injecting oil in a torque limiting clutch may impair its function. And this is true for a certain type of clutches, of which the clutch that we have in the FC5 unit is not. In the FC5 unit we will find a ratchet type of clutch, which is not this one, definitely. This is an industrial part that costs orders of magnitude more than the whole vacuum cleaner itself. However, the principle is the same, and I will use it to illustrate how it works. So whenever torque difference between this part and this part reaches a certain value, the bows who start will be able to overcome this sort of heel, the ratchet itself, and on the way up they will accumulate the energy in the spring that forces them down. On the way down, once the top is reached, they will give back this energy. However, the torque will be limited. It will be limited by the force of the spring it takes to overcome the heel. The friction coefficient has to be kept low in the process. That's why normally ratchet type clutches operate in a rather well oiled environment. Just take your, well, if you only can put it back then in shape. I mean, take apart your cordless drill and you're going to find something very similar to this one, and you'll see it's flooded with grease. And the grease is because in the ratchet type clutches, the function of the clutch itself and its rating is not a function of the friction coefficient between the bows or the ratchet and the crown. As simple as that. Friction is an undesirable component in a ratchet torque limiting clutch. Yeah, because a ratchet torque limiting clutch is normally, theoretically, in the ideal case, a zero energy dissipation device, unless, unlike a friction, because you see a friction would do that, and if it slides, definitely where it slides, you'll generate heat. That's it. So, in our FC5 unit, where this magnificent blower comes from, well, blower, turbine, sucker, the way you name it, it's magnificently made. So, in our FC5 we have something which is of this type. I cannot show it anymore because all the parts were corroded to a point where the clutch itself is completely destroyed and non-visible. But this is the type of clutch they have. They have a ratchet clutch. So definitely injecting oil into a ratchet clutch does nothing but extend its life. It's very benefic. So if you say that the presence of grease, oil, lubricant inside a ratchet type of clutch is unwanted, I would say no, it isn't. To the opposite. It's really an environment that does not depend on the friction coefficient between the bows and the ratchet crown. That's it. As simple as that. So if you want to inject oil into FC5, into your FC5 unit, and you bother about the clutch, well, don't. Ratchet type clutches are not affected by lubricant in a negative way. To the opposite, they are affected in a very positive way. So, thanks a lot for watching. If you have questions, feel free to bump the comment button. If you like it, well, like the like button. If you don't like it, exactly the same with the other button. Leave comments, and finally, as a conclusion, it's a happy ending story for everybody, because it happens that Kärcher cares, and they send me unexpectedly a very competent engineer to discuss the problem, and, well, I guess everybody will benefit from my poor, corroded Kärcher in the time I took to make those videos. Enjoy, have a nice day, have a nice evening, have a nice weekend, whatever applies. And keep on coming. I'll try to post some further videos on my other fetish, which is the angle grinder. Yes, I am an angle grinder fetishist, and I just plan to go and catch some parts away and see how fun we can get in the process. Alright, thanks for watching. Keep coming back. Bye-bye.